Hi there guys, back with another video. So what we're going to be dealing with today is our trigonometry. Now what's important is obviously reading information for the required, because sometimes within the required they are going to tell you specific facts. So we just need to make sure that all of the information on here is shown on our diagram. Okay, so now let's read. They say from the top of the building, the angle of elevation to the top of the tower is 75 degrees. So this angle here is 75 degrees. Now, if you're struggling with angles of elevation and angles of depression, what I always tell my students is that you actually have to almost put an eye level there, right? And it's horizontal. If you are looking up from that horizontal, it means it's elevation. And if you're looking down, it means depression. All right. So that's just to help you. It always has to be from the horizontal, not the vertical. All right. So now since we've discussed that, we've said that it's 75 degrees. And they say the angle of depression to the foot is 42 degrees. So this angle here is 42. Great. So all our angles have been inputted. If the distance between the two buildings is 50 meters, determine A, the height of the building. So we first need to figure out what is the height of the building BE. And then your next step is the height of the tower. All right. So now it's the whole tower AC. Okay, so let's attempt number one first. So they say to us that for A, it's the height. And that height is in terms of BE. All right. So what we need to do is determine what triangle we're going to use. Now, if we look at the sides we've been given, I have the 50 and I'm looking for BE. So technically, it's joining together to make that bottom triangle. But now we're in a predicament, right? But there's this triangle and it has no angles and I'm doing trig. So what now? Okay, the triangle has angles. Okay, you just have to input them. What you had to notice firsthand is that these lines here are parallel. And then you need to remember your fun angles, because if we look, there's that N or that Z, right? Which is alternate angles, which means that angle BCE, all right, is equal to angle DBC. So let's just write that down, because we need to inform them of everything that we're writing down. So we're going to say that angle BCE, that's this angle here, is 42 degrees. And your reasoning behind that is because of alternate angles. And you are going to tell them which lines are parallel to which lines. Perfect. Now I have an angle, I have a side length, and I have my unknown. I just always like to give it a variable, all right, so that I don't have to keep on using BE. So I just say BE equals X, okay? And you can say let BE equal X because you're inputting it. Now from here, what we're going to do is we need to remember our SOHCAHTOA. Now you can either write it as follows, or what some students are preferring is to write it downwards, okay, vertically. And the reason for that is because then you can just put your fraction line and there's your fraction. All right, your ratio. So if I'm looking at what I've been given, I have my adjacent side and I have the opposite that I'm looking for. So that means I have to use my tan ratio. And you'll see usually with these ones, tan is going to be that, but don't use that as your definite. All right, but usually that is the case. So you're then going to say, tan of the angle that you were using, which is 42 degrees, is equal to the opposite of X over the adjacent of 50. Then I need to get my X alone. So I need to take this 50 across, leaving me with 50 tan 42 degrees is equal to X. Thus, X must be the value of 45 meters if we are rounding it to the nearest meter. Thus, BE is equal to 45 meters. So there I've answered A. Okay, now we're going to look at B. So for B, what we need to know, all right, is we already have the length of DC, right? Because DC must be the same as BE because of the fact that those lines are parallel. So what we're going to tell them is that our BC is equal to our DC, which is equal to the length we just figured out, 45 meters. So we're okay with that. So we have this 45. So I'm halfway to the length of the building. Now I say to myself, but something here is not right because I still need to find this length. Okay. But we need to already fill in all the information that we have. Well, we know that this has to be 50 meters because those lines are equal in length. Okay. This line and this line. All right. And then I can see I have an angle, and that's the opposite side. So I'm going to then say that tan of my angle 75 degrees is equal to that length that I'm looking for of AD all over 50. I then take my 50 across, 50 multiplied by tan 75 degrees gives me that length of AD. So thus AD must be 187 meters rounded to the nearest meter. Now be very careful. That 187 only represents this top portion. They asked me, be very careful because that 187 only represents the top portion of the building. So we actually need to add both of those together to get the total length of the building. So therefore, our total length of AC is equal to that 187 plus the 45, which then gives us 232 meters. And that's the height of the tower. Okay, I hope this video was helpful. Please stay tuned for more videos on trig.